Hello friends, welcome to my channel Sulba Sutra Academy. My name is Sumit Mishra and I welcome you all for my third video lecture. The topic of which is LCM and HCF, which is the 1.2 chapter 1.2 or a real number, which comes under the real number. The first chapter, the exact chapter is 1.2, that is LCM and HCF. So before moving into the LCM and HCF, I want to explain you little bit about prime number and composite number. So let's understand first what is prime number. So prime number are numbers which have a factor of 1 and itself. It will not have other than any other factor. So what I told, prime number is a number which have a factor of 1 and itself. Take example 2, 3, 5, 7, 11, 30. Remember, 1 is not a prime number. So if someone will ask you, is 1 prime number? Say no. Okay. So it will not have any other factor other than 1 and itself. Okay. Then comes composite number. So what is composite number? So composite numbers are numbers which will have a factor of 1 in itself, and other than that it will have other factors also. Okay. So it can be represented as a factor of prime numbers. The 1 itself, and other than that there will be different prime factors also. For example, take the example of 6. So 6 can be represented in, so 6 can have a factor of 1, 2, 3 and 6. Similarly, 12 can have a factor of 1, 2, 3, 4, 6 and 12. So these are called composite number which have a factor other than 1 and itself also, like 2, 3, 4, 6, so whatever. So that are called composite number. Now the thumbs rule is each and every composite number can be represented as prime factors. Remember, this is very important. So every composite number can be represented as the prime factors. How? Let's see. Let's take an example of 18. So 18, if you will do LCM, so 2 9 ja, 3 3 ja, 3 1 ja. So if you'll see, 18 can be represented as 2 into 3 square, because 2 times 3 is there, so 3 square. Okay. So 2 into 3 square. As you can see, 2 is prime, 3 is prime. So 18 is a composite number, but it has been represented in the form of prime factors. Of course, the power can vary. For every different composite numbers, the power will be different. But the base things will be prime number only. So all composite number can be represented as prime factors. This is very important thing. Okay, now let's move on and understand about LCM. So what is LCM? So LCM is the product of the greatest power, of each prime factor involved in the numbers. What I told, LCM is the product of the greatest power of each prime factor involved in the numbers. So let's take two number. Let's understand what is the meaning of whole thing. Let's take two number 12 and 15. I need to find the LCM of both. So 12 can be represented as 2 6 ja, 2 3 ja. So 12 can be represented as 2 square into 3. Okay, then 15. So LCM, let's do the LCM of 15. So 3 5 ja and 5 1. So 15 can be represented as 3 to the power 1 into 5 to the power. So how many prime factors are there in both? So 2 square, 3 to the power 1, here also 3 to the power 5. So the prime factors present in both are of the form. So it will have a factor of 2, 3 and 5. Okay. Now we need to select the highest factor for each one. That means LCM of 12, 15 will be equal to, tell me, what is the maximum power of 2? It is 2 square. What is the maximum power of 3? You see, here also 3 to the power 1, here also 3 to the power 1. So 3 to the power 1. What is the maximum power of 5? 5 to the power 1. So the LCM will be 2 square into 3 to the power 1 into 5 to the power 1. That means 4 into 3 into 5. That means 60. So I will select always the maximum power here. So let's take any other example. So instead of 15, I will take, suppose, so 12, let it be 12 only. 2 square into 3 to the power 1. Let's take 18. So 18 can have 3 6 ja, 3 2 ja, 2 1 ja. So you can see it will be 2 to the power 1 into 3 square. Okay. Now see, 12 and 18 both have factors of 2 and 3 only, correct? So this is for your showcase purpose only. It will have a factor of 2 and 3. Okay. So what is the maximum power? So LCM of 12, 18 will be equals to. Now tell me, what is the maximum power of 2 over here? Correct. It is 2 square. Because 2 to the power 1 in 18 and in 12 it is 2 square. So I will select the highest power, that is 2 square. Then into, what is the highest power of 3 over here? Correct, 3 square. So 2 square into 3 square, that means 4 into 9, that is 36. So 36 is the LCM for 12 and 18. So hope you understood about LCM. Now let's move on to HCF. So what is HCF? So HCF is also called highest common factor. So what is HCF? HCF is the product of smallest power of each common prime factor, each common prime factor in the numbers. So what does it mean? So understand, highest common factor. So it is the product of smallest power of each common prime. See, in LCM it was not common prime. It was for all prime. But here which one is common, that only will be selected. And there smallest power will be selected for highest common factor. Got it right? Here only the common thing. So if you will see in the previous example, here I am selecting both the prime. So 12 and 18 has prime factor of 2 and 3. We selected the highest for 2 and 3. But if I will do over here in HCF, so product of the smallest power of each common prime factor. So we will select only the common prime number that is common between the 2 or 3 or n numbers of, if we are taking HCF of 2 or 3 or whatever number of numbers. So it will select only the common prime factor, and that also the smallest power, whichever is common, and their smallest power will be selected. Let's take example. Same example we will take, like 12. So first let's take the first example, 12, 15. Okay. So if you will see, 12 can be represented as 2 square into 3, and 15 can be represented as 3 to the power 1 into 5. Now can you tell me what are the common prime over here? This 3. 2 and 5 there is no common things. So in 12 there is 2 and 3, and 15 there is 3 and 5. Correct? So the common thing is only 3. Correct? In 15 also we have 3, in 12 also we have 3. In 12 we have other than 3 there is 2. That is not there in 15. So we will not bother about it. Similarly in 15 we have power of 5. That also we are not going to bother about it. Okay? Because it's not there in 12. Okay. So what is the smallest power of 3 over here in both? That is 3 to the power 1. So HCF of 12 and 15 is 3 to the power 1, that is 3. Now take example of 12 and 18. So 12 as we wrote 2 square into 3, 18 2 to the power 1 to 3 square. Okay. So what will be the HCF? So what is common over here? Both 2 and 3. So 2 is there in 12 also. 2 power is there in 18 also. Similarly 3 to the power 1 is there on 12 also. 3 is there in the 18 also. So HCF will be given as the smallest power of 2. So what is the smallest power of 2? So 12 has 2 square, 18 has 2 to the power 1. So the smallest is 2 to the power 1. So I will select 2 to the power 1 into, in 12 we have 3 to the power 1, 18 we have 3 square. So what is the smallest one? 3 to the power 1. So 2 to the power 1 is 2, 3 to the power 1 is 3, so 2 into 3 is 6. So we have got HCF at 6. So hope you have understood this basic concept of LCM and HCF. Now in the next video, or let's move on, not next video, here only we will start doing then the problems. Okay, so let's move to the chapter. Let me make clear it. Okay, so let's do the chapter from NCERT class 10 mathematics. So let's do. So we have exercise 1.2. So in exercise 1.2, first question is express each number as a product of its prime factors. So 1 as a prime factor, I need to represent 140. So 140 we will do LCM 270 2 3 5 7 7 1. So 140 can be represented, since there are two 2, so we can write it as 2 square into 5 into 7. We don't write 1 because 1 into because it's not a prime number, so we don't write 1. As simple as that. So 140 we have represented as prime factors. Let's do the second problem. 156. So take LCM for 156. 278. Okay. 2 3 ja 6, 118, 2 9 ja 3, 13 ja 13 to 1 ja. Okay, so 156 can be represented as, since there are 2 2, so 2 square into 3 into 30. Okay, next, third is 3825. So let's do again LCM. So 3825, since 5 is there, so it will go by 5 for definitely. So 5 7 ja 35, 3 32, 5 6 ja 30, 2 25, 5 5 ja 25. Now 5 again I'll take because 5 is there. So 5 1 ja 5, 2 26, 5 5 ja 25, 1 15, 5 3 ja 50. Now it will go by 3 because 3 5 ja 15, 3 1 ja, again 51 will go by 3, it will give me 17. So 17 1 ja, 17 is a prime number, so I took 17. So 3825 can we see here we have 2 3, 2 5 and 117. So since it is 2 3, so first I'll write 3 square, then we have 2 5, so I'll write it as 5 square, and then 70. So it's better to write in increasing order. That's why I first wrote 3 power for 3, then I wrote for 5, and then 17. Okay, let's move on. So the next number is 5005. Okay, so fourth question is 5005. So let's do the LCM again. It will go by 5 1 ja 5, 0 0 1. Then it will go by, since it is 1 over here, so it can go by, see, it should be always, it should have 1 in the end. That is the most important thing. Any number which is which is ending with 1, or which unit digit is 1, that will go with it. So let's do with 11. So 11 9 ja 99, 111, yes, it went. Now 91, we know that it will go by 13 because it comes in the table of 13. So 13 7 ja 7 1. So we'll write 5005 in the increasing order, of course. So it will be 5 into 7 into 11 into 13. Very good. So far so good. Let's move on to the final one of question 1. It's 7429. 7429. Let's do LCM. So This is very trickier one. So see, it's ending with 9. So any digit which will, so 9 comes in the table of either 3 or 7, correct? So we need to take multiple for a number whose unit digit is 3. Okay, so let's try with 3 first. So 3 2s are 6, 114, 3 4s are 12, 222, 3 7s are 21, 1 19, 3. So it didn't go. So what is the next number I should take for 3 only? Let's take 13. Will it go? 13 5s are 65, 9 92, 92, 13 7s are 91, 1 9. Okay, so it didn't take. So now try with 7. 7 6, so 7 is totally going. 42, 7 6 9 is there, so not going. So 17, so 17 4 68, 6 62, 17 3 51, 11 119. Yes, it's going by 17. So 17 4 68, 6 62, 17 3 51, 11 is remaining, then 9 will come, so 119, 17 7 190, 119. Next, so I got 4 3 7. Now 7 comes under table for 7, 3 and 9. So 3, 9 and 7 table gives. So we have already seen 13 didn't divide the top one. So 3 and 13 will be cancelled. So let's check with 23. So 23 1 23, 20, 207. Yes, 23 9. Yes, it will go by 23. So 23 1 23, 20, 207, 23 9. Of course, if we had tried by, since I was trying with 3, you might, if you will go by 9 also, so 19 you might have got it. Okay, so 19 1. So finally we got 7429 equals to 17 into 19 into 23. So this is for question number 1 is done. Now, okay, so to move further, I want to tell you one more thing, the formula which I didn't tell till now, that LCM of any two number, okay, so LCM into HCF equals to product of the number. So this formula is very important. So if two number is given and any one of LCM or HCF is given, you can easily find the other things. Either LCM or HCF will be given and will tell you to find HCF or LCM. Okay, so this formula is we are going to use in the next problems. Okay, so the first problem is find the LCM and HCF. Second question is find the LCM and HCF of the following pair of integers. Verify that LCM into HCF equals to product of the two numbers. Of course. So let's take Let's clear it first, otherwise. So I am moving to the second question. The first problem is 26 and 91. We need to find LCM and HCF, and then have to prove LCM into HCF is the product of the two number. Okay, so let's do the LCM part first. So 26 can be 2, 13, 13, 1. Now 91 is coming in 13 table. It's coming in 13, 7. Yeah, so let's take 7. So 13, 13 and 1. So 26 can be represented as 2 into 13, and 91 can be represented as 7 into 30. So LCM will of 26, 91. You remember the highest power. So what are the prime factors over here? 2, 7 and 30. Correct? Now tell me, what is the highest power of 2? It is 2 to the power 1. If nothing is there, that means 2 to the power 1. That is 2. Then what is the highest power for 7? That is 7 only. Now this also has 13 to the power 1. This also has 13 to the power 1. So what is the highest power? 13 to the power 1. Okay. So that means 13 only. So 2 into 7, 14. 14 into 13 is 14 10 is 140. 14 3 is 42. So total 182. Okay. Now HCF. So in HCF we need to look for the common prime of 26, 91 equals to. Now what is the common thing over here? Only 13, and their power is, for both is 1 only. So the smallest power is 1 only. So we will write HCF equals to 13 to the power 1. That means 13 only. Okay. Now let's prove the second part. LCM into HCF equals to product of the number. Okay. So let's multiply then LCM into HCF. So this is our LHS. LHS is LCM into HCF. That is equals to 182 into 13. So 13 into 2 is 26. In hand we have 2. 13 8 is 104. 104 plus 2 is 106. So 6. In hand we have 10. 13 1 is 13 plus 10 is 23. So we have 2366. Okay. Now find the product. So RHS is product of number. Product of two numbers. So product of two numbers will be equal to 91 into 26 into 91. So 26 1 is 26. So 6. We have 2 in hand. 26 9 is 29 is 180. 9 6 is 54. So 180 plus 54 is 234. 234 plus 2 is 236. So you see LCM. So we have got both as 236. So yes, we have got LHS equals to RHS. Hence proved. So it proved that LCM into HCF equals to product of two numbers. Okay. Now let's move on. So the second problem is 510 into 92. Second problem is 510. second problem is 510 92. Okay, so let's do for 510 first. So since 0 is there, so it will go by 2 and 5, remember that. So 2 2 ja 4, 1 11, 2 5 ja 10, 1 10, 2 5 ja 10. Now 255 is there, it ends with 5, so it will go by 5. So 5 5 ja 25, 5 1. Now 51, we know that it comes in the table of 3 and 17. So 3 17 17 1. Okay, similarly we will do the LCM for 92. 2 4 ja 8, 46, 2 23, 23 1. Okay, so it can be written as 510 equals to 2 into 3 into 5 into 17. So all have a power of 1 1 1 1. Okay, then 92 can be written as 2 square, since there are 2 are there, so 2 square into 23. Okay, now LCM of 510 92 will be given as, so what is the highest factor for 2 is 2 square into, what is the highest factor for 3? 3 only. What is the highest factor for 5? 5. What is the highest factor for 17? 17. What is the highest factor for 23? So 23. So if you will multiply this, then we'll get, so 2 into 2 is 4, 4 3 is 12, 12 5 is 60, 60 into 17 is 1020, because 17 into 6 is 102, put 10 over there, so 1020. Now 1020 into 23, so 23 into 100, remove this 0 for the time being, so 2300, 23 to ja 46, so we get 2346. Okay, and then put 1 0 over here, whatever 0 was there, so put it over here. So we got it as 23460. Okay, then HCF of 510 and 92 will be, what is the lowest factor? So what is the common thing first? 2 only. Other than 2, nothing is common. And also, what is the minimum power of 2? That is 2 to the power 1. Because 510 has 2 to the power 1, 92 has 2 square. So the minimum is 2 to the power 1. So we got HCF as 2. Okay. Then, yeah. Now we need to find the next portion, LCM into HCF equals to product of two numbers. Okay, so let's, LHS is LCM into HCF, that is equals to what? LCM is 23460, HCF is 2. So 0, 6 2 is 12, 1, 4 2 is 8, 1 9, 3 2 is 6, 2 2 is 4. So 46920, and RHS will be the product of two number. Product of two number. So that can be written as 510 into 92. Okay. So remove 0 for the time being. 92 into 51. So let's multiply first 92 into 50. From 50 also remove 0. So 92 into 5. That gave us 19, 5 is 450, 460. So 92 into 50 will be 4600. 4600 and 92 into 1 is 4692. 0. Now this 0 I will put it. So 46920. So hence proved that LHS equals to RHS. So this we proved it. Okay. So let's move on to our third problem in this. Second question, third problem. So what are the numbers? 336, 54. Okay, so let's do LCM for 336. 2, because 6 it is ending with 6, so it will be divisible by 2. So 2 1 ja 2, 1 13, 2 6 ja 12, 1 16, 2 8 ja 16. Then again 2 8 ja 16, 2 4 ja again 2 42, again 2 21, 3 7 7 1. Now let's go for 54. 2 27, 3 9, 3 3 3 1. Okay, so 336 can be represented as, how many 2 are there? 1 2 3 4. So I can write 2 to the power 4 into, how many 3 are there? 1 only. So 3 to the power 1, then 7 to the power 1. Similarly 54, if you want not to write power 1, that is also fine. You can write 3 into 7 also. So 54 can be represented, how many 2 are there? 1. So 2. How many 3 are there? 3. So 3 cube. How many 3's are there? Based on that we determine the power. Okay. Now tell me about LCM. LCM for 336, 54. So what will be the LCM? The highest power. Now think about, so what are the prime numbers over here currently? 2, 3 and 7, correct? What is the highest factor, what is the highest power of 2 in this? Both. So here it is 2 to the power 1, here it is 2 to the power 4. So the highest is 2 to the power 4. Now tell me about 3. What is the highest power of 3 over here? 3 cube. Now 7. In the second one 7 is, so highest power is 1 only. So 7. Okay. So 2 to the power 4 is 2 to the 4 to the 8 to the 16. So 16 into 3 cube is 27 into 7. 16 into 27 into 7. Now 16 into 7 is 112, and 112 into 17. 112 into, not 17, 27. So 27 to the 54. In hand we have 5. 27 1 is 27. 5 32. So 2. You're left with 3. 27 1 is 27 plus 3 is 3024. That is our LCM. Okay. Now let's do HCF. So HCF of 336 and 54 can be given as, so the common thing only. So what are the common prime over here? 2 and 3. 7 is not common, only 2, and because 2 is over here and 3 is over here. Now tell me what is the lowest, the smallest power of 2 and 3. So the smallest power of 2 is 2 to the power 1, and what is the smallest power of 3? That is 3 to the power 1. That means 2 into 3, so 6. So 6 is our HCF. Now second portion, LHS. So LHS is LCM into HCF. Okay, so LCM into HCF will be 3024 into 6. So that will be given as, what is 24 into 6? 20 into 6, 120, 4 into 6 is 24, 144. And 3000 into 6 is 18,000. Correct? So 18,144. 18,144. Now RHS is the product of numbers. Product of number. So what are the numbers we have? 336 into 54. These are the two numbers. So 336 into 54. Okay. Let's multiply. 54 into 6. So 50 into 6 is 300. 4 into 6 is 24. So 324. So I will write 4. 32 is in my hand. So 54 into 3 is, 50 into 3 is 150. 4 into 3 is 12. 162 plus 32. 162 plus 32 is 194. So 4 we have in hand 19. Okay. So 162, 54 into 3 is 162. 162 plus 19 is 181. So we have got 18144. So LHS equals to RHS. Proved. Okay. So let's move on then. Our next problem. So our next problem is, find the LCM and HCF of following integers by applying the prime factorization. Okay. So let's do third problem, question 1. What are the numbers given to us? 12, 15 and 21. 12, 15, 21. So 12 you can do LCM type also. I am directly writing because this is very easy thing. So 2 square into 3. 15 can be written as 3 to the power 1 into 5 to the power 1, and 21 can be written as 3 to the power 1 into 7 to the power 1. If you wish, you can write power 1 or you can leave it also, it doesn't matter. This is for understanding purpose only I have written. So LCM of 12, 15, 21 will be. So first tell me, what are the numbers available, prime numbers available to us? 2, 3, 5, 7. Correct? Now tell me, what is the highest factor? What is the highest power for 2 in 3, all 3? So highest power of 2 is 2 square. Now tell me, what is the highest power of 3? That is 3 to the power 1. What is the highest power for 5? 5 to the power 1. What is the highest power for 7? 7 to the power 1. So 2 square is 4, 4 3 is 12, 12 5 is 60, 67 is 6 7 is 42, so 67 is 420. Okay, then comes HCF. So HCF of 12, 15, 21. What is the common between all 3? That is 3. only 3 is common over here. You can see over here. And what is the smallest power of 3? That is 1. So HCF will be 3 to the power 1, that is 3. Okay, let's move on. So our second problem is 17, 23 and 29. See, all are prime numbers. 17, 23, 29, all are prime numbers. So we can't write it as a factor because we know prime numbers is divisible by 1 and itself. So of course 17 can be written as 1 into 17. We generally don't write 1, so you can write 17 also. It doesn't matter, 1 into 17 also you can write. But so LCM, I can say LCM since of 17, 23, 29 can be given as what is the maximum factor, the prime factor. So see, 17 is a prime, 23 is prime, 29 is prime. So there is no factor for it. So LCM will have factor for 17, 23 and 29. What is the maximum power of 17 over here? 17 only. What is the maximum power of 23? 23 only. What is the maximum power of 29? 29 only. So now multiply. So after multiplication, if you'll see, we will get, first multiply 17 and 23. So how much we will get? So 72 is 34, so 340 plus 17 into 3 is 51. 340 plus 51 is 391. Sorry, 391. Now 391 into 29. Okay, so 29 into 1 is 29. We have 2 in hand. And 29 into 9 is 29 ja 180, 9 9 ja 81, 180 plus 81, 261, 261 plus 2 is 263. So we are left with 26. 29 3 ja 20, 87. 23 is 60, 9 3 is 27, so 87. 87 plus, how much we left with? Plus 26. So 87 plus 26 is 113. So we got 11,339. So this is our LCM. What will be the HCF? Is there anything common? 17, 23, 29. Is there any factor common? No, there is nothing common. 17 is 1 into 17. 23 is 1 into 23. 29 is 1 into 20. So what is common between all three? That is 1. So if nothing is common, that means 1 is the common factor. So we will write HCF as 1. Okay, let's move on. Let's do the fourth problem. What is the fourth problem? We have given HCF, is telling to find LCM. So we'll apply the formula. You remember HCF into LCM is product of two numbers. So we have given HCF of 306 and 657. This is given as 9, and he's telling me to find LCM. Okay, so what is the product of two numbers? So what is the product of two number? 306 into 657. Yeah, this is the bigger one, I'm not going to do it. I have already done. So you need to do it in there. Actually, let's first write, instead of finding, we can do first is LCM into HCF equals to, this is the formula, product of two number. So what is LCM? We don't know. So LCM, what is the HCF? 9. That is equals to, what is the product of two numbers? 306 into 657. So LCM similarizes, LCM equals to 306 into 657 divided by 9. So 9 3 ja 27, 336, 9 4 ja. So 657 into 34. So this one we need to multiply. So this we can multiply easily. So 34 into 7. 30 into 7 is 210. 4 into 7 is 28. So 238. So 823 is in my hand. So 34 into 5. 30 into 5 is 150. 4 into 5 is 20. So 150 plus 20 is 170. And 170 plus 23 is 193. So 3, we are left with 19. So 34 into 6 is 30 into 6 is 180. 4 into 6 is 24. So 204. 204 plus 19 is 223. So we got LCM as 22338, 22,318. So this is our answer. So they want to know about LCM. We got the LCM. Okay. Let's move on. The fifth number problem. So what it says, check whether 6 to the power n can end with the digit 0. He is asking whether 6 to the power n will end with digit 0. Remember always, if they are telling you to find anything related to 0, so 0 will come only if it has a factor of 2 and 5. At least one should be there. 1 of 2 and 1 of 5. At least. It can be more than 1 also. But at least 1 2 and 1 5 should be there to get the digit 0. Then only it will end with 0. As simple as that. Because 2 into 5 only gives 10. There is no other number. Of course, 0. 10 into 10 you can get. But the basic thing is, if it is some power wise. So see, when you are writing in the prime factor form, there will be no 10. Of course, right? So it can have only a prime factors. I told you composite number is represented as prime factor. So when you get the LCM, it is a prime factors. So to get 0, you have a prime factor of 2 and 5. Now 6 to the power n, if you will see, so 6 can be written as 2 into 3 to the power n. So x into y whole to the power n is x to the power n. So 2 to the power n into 3 to the power n. As simple as that. So there is no 5 over here. So it has a prime factor of 2 and 3 only. And there is no 5. There is no factor of 5. Hence, it will not end with 0. As simple as that. 2 is there. You can see 2 is there. The power for 2 is there, but there is no power for 5. At least one 5 should be there, but that is not here, hence it will never end with 0. Okay, yeah. Let's move on to question 6. So question 6 says, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 plus 1 plus 5 to 1 plus 1, sorry, are composite number. Okay, so the first thing is 7 into 11 into 13 plus 13. Okay, so you see we have two numbers, there is plus in between, so you can see 13 is common over here. Okay, so I'll take 13 common. So if I'll take 13 common, what I am left with in the first section, 7 into 11 plus, if 13 I took common, what I left with the second one, 1. So 13 into 7 into 11 is 77 plus 1, that means 13 into 78. Okay, so which means now 78 can be, so 78 comes in the table of 13, 13 6 ja 78, so 13 into 6 can be represented as 2 into 3, so we get as 2 into 3 into 13 square, correct? So as you can see, this has a factor other than the number and 1. Okay, like 2 is the factor for it, 3 is the factor for it, 13 is the factor for it, so it's a composite number and not a prime number. You remember, prime number is something which have factor of 1 and itself, but here if you will see, it has a factor of 2, 3, 13, 13 square, 2 into 3, 3 into 13, so you can make a different factors. Okay, hence the given expression is composite and not prime. Okay, next in the same problem we have one more expression. What is that? So we have 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Okay, so we have second expression as 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. This is my second expression. See over here we have 5 common, so I'll take 5 common and I can write it as 7 into 6 into 4. So since 5 is common, so this 5 will not come. 4 into 3 into 2 into 1 plus 1. So this can be written as, so 1 into 2 is 2, 2 into 3 is 6, 6 4 ja 24, 24 6 ja 144, and 144 into 7. 144 into 7 is 100 into 7 is 700, 40 into 7 280, 4 into 7 28, so it will be 1008. So I added all, I got 1008. So 1008 plus 1, so I got 5 into 1009, correct? So as you can see, this things has a factor of 5, correct? It's not required. If you will leave it like this also, it's fine. It has a factor. We know that it has a factor of 5, common factor of 5, other than 1 and itself. But it's better to do it. So it has a factor of 1009 also, other than 5. So 5, 1009, 5 into 1009. So all these are factors for it. Okay, hence this also has a factor other than 1 and itself. Hence this also is composite and not prime, because it has a factor other than 1 and itself. Hence it is a composite number. Okay, let's move on to question 7. This is the final question. What is the question saying? So there is a circular path around a sports field. Sonia takes 18 minutes to drive one round. Okay, for Sonia it is 18 minutes per round. Okay, and while Ravi takes 12 minutes for the thing. So for Ravi it is 12 minutes per round. Okay, so he is telling, suppose they both start at the same point. Understand like this: Ravi and Sonia both started from the same point only, and at the same time, and go in the same direction. So both started from same point, same time, and same direction. It's not opposite or some other direction. Okay, so after how many minutes will they meet again at the start? So as you can see, Ravi is faster, right? So Ravi will complete, they will leave each other. Ravi is faster, so he will go faster. Sonia will be little bit back than it. Okay, now when they will meet again, so he is telling when they will meet again at the starting point. So when they will meet again at the starting point, of course, since Ravi is faster, so suppose after X round they meet. So Sonia, when Sonia will cover X rounds, Ravi will go for X plus 1 round. Remember, it will have one more than this. Again, after Y round, again they will meet. But in that case, Ravi will be Y plus 2 rounds. So in that case, he will have a, 2 rounds more than Ravi. So first time when he will meet, he will have an upper hand of 1 round. When second time they will meet, Ravi will have upper hand of 2 rounds. Then Sonia. Understand this basic concepts. This is very important. I don't know the number of rounds. For the time being, whatever rounds are there, suppose in 6 round if they are meeting, then if Sonia will cover 6 round, Ravi will be 7 round first time. Then suppose after 12 round they are meeting, so Sonia will complete 12, but Ravi will complete 14 rounds, because one round he got hands over previous thing, and when second time they meet, again one round more than that. So this is very important thing too. Again, after when they will meet, Ravi will have a upper hand of 3 rounds. That is, Ravi will revolve 3 rounds more than Sonia. Okay. So this is the very basic things to understand. Once you understand the core logic, then you will able to solve the problem. Okay. So now, he is asking at what time? Same time. So after how many minutes? So I know the round, upper round, how much upper round they have. How much upper round Ravi has over Sonia. Okay, but he's telling me when they will first meet. After moving this point, his first meeting. That means whatever round Sonia will cover, plus 1 round Ravi will cover. That is for sure. Okay, so when they will meet, understand the basic thing. when the first time after they start, when the first time they will meet again, understand it will be a multiple of, I mean the common multiple of the both Sonia and Rabi, correct? Then only it can meet. Am I right or wrong? So it should be the common multiple. Okay, that means Sonia is covering 18 minutes, right? So for first round to complete she needs 18, second round she needs 36, and third round, to complete third round she will take 54. Next round, I mean I'm talking about the starting point. So first time it took 18, second time 18, third time, sorry, second time 36, third time 54. So at 54 she will be again at the same instance, then 72, like this it will go. Similarly, when Rabi will start, he will go like 12. First round he will complete in 12. Second time he will be at the initial point at 24 second. Next time that when he will go for third round, he will reach at the starting point at 36 second. Okay, then 48. So can you see this? He is meeting at the starting point both at 36. So with this method, and so it should be the LCM of 18 and 12. This is just for your understanding purpose. Okay, so we are going to do that whenever he will meet, it should be the common multiple of 18 and 12, because next time he is asking when he will meet at the starting point itself. Okay, he doesn't ask me any other place. He's talking about, the question is talking about only the starting place. So when first round for Sonia it is 18, second round for Sonia is 36, she will reach at the starting point. Third round 54 seconds she will reach the starting point. Fourth round 72 seconds she will reach the starting. Similarly, when Rabi will go first round, he will complete in 12, he will again come at the starting point. Second round he will go 24 seconds. At the 24th second he will again at a starting point. When third round he will make, then at 36 second again he will be at starting point. 48 second, 4 round he will complete, and he will again come at the starting point. So answer is quite without doing any LCM, I am telling you 36. This is the basic thing, because starting point the question is asking, so I can do it if it is a suppose objective question and all. So without doing LCM and HCF we can do like this, but since we have to do with LCM, so of course they will meet at the LCM, the lowest common multiple time of 18 and 12. Okay, so whatever will be the LCM, because that time only they will meet again at the starting point. That is for the first, since they are telling me about the first time. But if they will ask for second time, then you will not get the using the LCM. Got it, right? So the second time again will be the factor like this only. What the next factor we will go. Okay, of course it will be 72, because 12 into 6 is 72 if I'm not wrong. Okay, so the first time they will meet, that will be the LCM for 18 and 12, as simple as that. So we need to find LCM of 18 and 12. So let's do 18, 2, 9 ja, 3, 3 ja, 3, 1 ja. Now 12 can be represented as 2, 6 ja, 2, 3 ja, 3, 1 ja. So 18 can be represented as 2 into 3 square, and 12 can be represented as 2 square into 3. So LCM will be given as, what is the highest factor for 2? Is 2 square. What is the highest factor for 3? Is 3 square. So 2 square is 4, 3 square is 9, so it is 36 seconds. So at 36 seconds they will meet again at the starting point. So my answer is 36 seconds. I hope you got all the problems. If you have any doubt, please raise your doubt in the comment section, or I have a Facebook page dedicated to this, so you can raise your question over there also. Okay, I hope you liked the video. If you liked, please click the like button and subscribe to my channel for further videos, and also share this video with your friends and on the social network. Okay, so I hope you like the video. So let's meet in this next lecture with some new topics, that is chapter 1.3. Okay, see you till then. Bye, take care.